I was noticing in that last clip that there was some sheen changing on this helical gear as well as this balancer on this side. The lights in my shop are fixed lights, so they don't swing, they don't move, and the only reason that you would see flashing or changes in the sheen off of this helical gear as this was being turned would be because that plane is changing somehow, that surface is changing in the light. I also saw changes in the harmonic balancer. So concern would be in a top out situation where obviously everything stopped pretty abruptly. Did we actually bend a crankshaft? Are there other issues maybe in a crank bearing? Things of that nature. So it took a little bit of thinking. Honestly, I was pretty grumpy for a little while. What we've got set up here is a dial indicator, and I went ahead and pulled the spec sheet service manual for the runout on a crankshaft. Now, in the service manual, you see in that little clip, you're supposed to check it on the shaft closer to where the balancer sits. I guess this just might be a balancing plate. And then also on the flywheel, where the flywheel and this gear actually mounts to the crankshaft. Now, without disassembling everything, the nature of levers, fulcrums, the farther away from the pivot point, from the fulcrum, the greater the play. So, manual says runout should be less than 0.0012, so less than 12 thousandths. What I'm hopeful of is that if the end of this crankshaft, and we'll check the flywheel side as well, as long as this is within spec, then I'm going to assume the crankshaft is probably going to be okay and we can run it. And whatever I'm seeing as far as the change in the light on the gear is because maybe this is ground a certain direction, and so it catches the light because there's grooves on the side of the gear. Same thing could exist on the balancer. My hope, when we run this dial indicator, I'll kind of show you the setup. Hopefully we're within 12 thousandths, and then we can just put this thing back together. But if not, we might have to do further inspection. I'll be honest, guys, I don't really want to split the case on this, but we'll see what happens. So this setup here, you've got a set of vice grips, and it's fairly tight. I use this so I'm not scratching the paint on the frame. This has a lever that gives you a specific adjustment. This is kind of nice. I've seen magnetic ones, but most of this is aluminum. It's hard to get it lined up. This is somewhat of a flexible arm that once you get everything cinched down, you throw this lever and it will lock this into whatever position you have. The dial indicator is set, and I haven't zeroed it. Was going to get this on camera for you, but dial indicator is set that when this needle moves, this arm will move on the gauge and give you an idea how much movement there is as a function of what you'd call runout. Now, I'm a little bit off center here. You want this right in the middle. So I'm going to see if I can make a minor adjustment to how this is oriented. Tighten it back up, and that looks a little bit better. You'd want this right at like the top, a true tangent line, if you will, perpendicular to the center of this hole. This dial indicator has adjustment screw here. You can see just the lightest touch on that wiggles. I want to go ahead and zero this to wherever, maybe, oh, I've got this on here too far. That's the problem. Let's back this out just a touch. We'll move this up about here. We'll have to reset our arm and bring this down. There's plenty of free play in this arm, so you don't want it to just be right at the full extension. Ideally, you move this in a little ways. Go ahead and cinch this down so that any motion in this will actually cause movement. It looks fairly stable. I don't see anything moving. Now we'll go ahead and adjust our dial to zero out our gauge. Give it a second, just make sure nothing's moving. Feel pretty comfortable with that. Not that this has to be perfect. You're going to see the change in values, and that's really what you're trying to measure. Some guys like to get this right on, and I'm not the best with this. I'm far from a machinist. So feel free to let me know about it. We'll get this kind of set to where I know that it's moving. And hopefully we can get it kind of close to a 0. I don't think I'm going to get it super good, but that's pretty close. The hope is that if there's any movement in this shaft, this way or this way, as I turn the flywheel, we'll see how much change there is. So, let's go ahead and zoom this in. Looks like we from the high to low, how many increments apart are we? It looks like we're about 0.8 thousandths. So there's definitely some run out. I think we're actually okay. It does look like there may be some issues in the, most likely the crankshaft bearing, at least on this side, which makes sense. Bearings are soft. They're supposed to give before the crank does. Hardened steel, like the crankshaft is, it takes a bit to tweak it, but abrupt stops are pretty rough, and I don't know what the situation was when the owner blew up the top end. So I'm going to check the other side, kind of see what happens, and then I'll give you an update.